Thank you. A quick update. Actually, I'm not at HP Cloud anymore, as of about a month ago. You might have heard some news, I'm not saying anything that isn't public already, about their public cloud. I still want to solve that problem. I think having both a very large public cloud and a bare metal public cloud is a really interesting challenge. So I went over to IBM to work on it there. I've been working on OpenStack for over 3 years now, coming up on 4. Also, I tend to be kind of silly, and I love interactive audiences, so feel free to just yell questions now and then if something's not clear. Yeah. Also, I got back from Tokyo a week ago, so I'm still a little fuzzy on the jet lag, and maybe from drinking Yoichi. Sort of a little background before I jump into Ironic itself. This whole thing about virtual machines, like it's an abstraction of a computer. The whole power of that is by defining our infrastructure as code and modeling computers in an abstract way, we can move them around, we can scale them up and down, we can treat them like little building blocks. And containers give us pretty much the same thing, the abstraction's a bit different, but we can still treat our infrastructure in this abstract way. And that's been really powerful. We've seen, I know, I've been working in sysadmin things for about 18 years now. I've seen a lot of change in that area. There's sort of a correlation between this is a Google Trends search for the keywords virtualization and cloud computing. And there's a sort of correlation when virtualization starts to fall off and cloud computing became the buzzword du jour. But it has really changed how all the companies that I consulted with, most of them, how they developed software, how they developed large websites, right? That changed as virtualization became so ubiquitous. I don't know if there really is a correlation here between those buzzwords and these ones, but about the same time that cloud computing peaked, DevOps became a thing, which is really this movement of operations into defining your systems as code. And OpenStack started around the same time. I certainly hope those two things aren't linked. It's just a coincidence. But I.
In the back, can't see the time axis. That was when we mentioned 2011.
Nope. Wait, how do we get there? There we go. Yeah, time axis. I guess Google Trends starts around 2011 to end of this year. Okay, but I'd like to posit that if sufficiently abstracted, any physical machine will behave just like a virtual machine. So all of the advances we've had in software-defined infrastructure, in automation, in deploying things in clouds and scaling up and scaling down, those exact same changes and all those benefits apply just as well to hardware if we abstract it sufficiently and in the same way. So this is what I did about 2.5, 3 years ago. OpenStack didn't have that. It was just a cloud platform and an open source one, and that's better, I think, than closed source ones. But we thought, what if we put underneath OpenStack an abstraction that could control hardware? While we were discussing this, some folks in Japan and Korea, I think, NTT Docomo, USC, and one of the Intel labs in Southern California got together and made a sort of proof of concept for Nova. It's the OpenStack Compute project, specifically for HPC workloads and kind of related to the previous talk, gene modeling and things like that, right? They wanted to run all the jobs they were doing in a cloud, but get the full performance of bare metal. And so they sort of hacked it together, and it didn't quite work all that well, but it worked well enough. And I collaborated with them. They sort of handed off the project to me and turned it into what it is now, which is basically just a consumption API for compute resources. That's a cloud, and a hardware abstraction service underneath it that is not exposed to users. So along the way, some of the contributors, because it's a delightfully open source project, most people are paid to work on it, but sort of not following a specific agenda, and some of them are just interesting people who drew that as our mascot. Because it's, bare metal. And then there have been some riffs on that bear that are kind of funny, but I can't show them. Yeah, we had a couple other name ideas for the project, all around the how many puns can you make about bare metal and ironic and bad rock bands, and yeah, it got fun. But we settled on this name after the Portland summit, because Portland's rather ironic. Okay, so what does it actually look like? I kind of can't harp on this point enough. It's just the same. The interface as a user to get a physical machine through this service is exactly the same as a VM. So if you've ever used OpenStack, Nova Boot looks like that. The only difference here is the flavor. I'll get more into how that works under the hood in a bit, but that abstraction has enabled really all of it. And it's also a little bit more complicated than that, because there are some things that you can't do with the physical machine yet, if they're not abstracted enough. Some network things are kind of fixed, like the MAC addresses. You can't just tell the machine what its MAC address is. It's actually in the firmware. Same thing for storage. So some of the primitives you might have in a cloud, like defining your own networks or defining your own storage or attaching volumes or doing a live migrate or clone of an instance, the abstraction kind of breaks down there, and we're working on that, but not there yet. The other angle I came at this from is in my previous life as a consultant, pretty much every company I worked with had built their own system for deploying hardware using PXE boot and IPMI or whatever, but everyone was different. As a sysadmin myself, I've really disliked having to rewrite my own things. When I left one company and went to another one, if it wasn't open source, I had to build it again, and that frustrated me. And then seeing other developers or sysadmins just reinventing the same wheels. Like, let's all collaborate. We all move faster when we collaborate. Rather than building, the way a machine is installed in this company is different than in that company, is different than in that company. Let's just have one. But also, the whole model we have in a cloud of every machine starts from the same golden image, turns out that works better. There's less entropy. The initial state of the machine is guaranteed across time and across number, which is not the case for an installer, an ISO, right? Especially if your pre-seed file says, oh, also do some package updates during the install, you're going to get a different result every time, or at least you don't control that result. So we took the approach, again, from the cloud of a guaranteed initial state. And Ironic does just a binary image copy every time. This is pretty much the difference between the two approaches. I don't know that I need to walk through it entirely, but a couple things to point out. The provisioning service, whatever you're using, and Ironic's going to actually just pull a QCOW image or a tar.gz of a machine image down. The boot process will be the same with PXE, IPMI, et cetera. And then instead of doing an install, it just writes it to the disk. It may or may not partition the disk, but it just writes the image to the disk and then continues. The parameterization of the instance, that is, setting a password, copying in an SSH key, getting an IP address, that kind of stuff, any init scripts you want to run are done the same way on the cloud, right? Cloud init or config drive runs them after the image is written down to disk. I'm going to dive into the system architecture for a bit, because scalability kind of interests me, and running like larger things is more fun than small things. There's an API tier, RESTful service. Run that in Apache or Nginx, it doesn't matter. Scale it out just like you would normally scale out any web service. Pretty lightweight. There's a Rabbit bus, or an AMQP bus, we usually use Rabbit. A database, we usually use MySQL. And then there is, what really does the work are these other Python processes we call the conductor that use a distributed hash ring, or sorry, a consistent hash ring to map all the hardware in your pool across that ring. if you have to do an upgrade or a server goes down, the machines that are being managed are remapped across that ring, ideally seamlessly. Any in-process actions might fail, but they get remapped and managed by someone else. And then also to call out here is the sort of drivers, right? There's a lot of different hardware out there with different management interfaces. Dell, HP, I don't know, they're all pretty much different. Most things talk IPMI, not everything does, and that's kind of just a baseline. There's a lot of stuff you might want to do that isn't part of IPMI yet, never will be. So Ironic is pluggable internally. And I don't know if it's by being open source or by being part of Openstack, but all the hardware vendors have been writing drivers and adding those drivers to Ironic. So that's actually a list of, from the latest release, Liberty, of all of the hardware vendors that have contributed their drivers to Ironic to manage their hardware. And they're continually playing catch up with each other to add more features. So as soon as one of them does something like adds RAID support, so you can do an out-of-band RAID array build or delete. Pretty soon the next hardware vendor adds that too. That's been a really interesting social dance as hardware vendors are coming together to try and get their feature in first and trying to make sure everyone moves together, the product stays consistent. We've also got a couple just test drivers on the right side there. We just use those for testing. I'm going to actually demo one if I end up with time at the end here on a Nook. And then at the top are the sort of standard reference open source drivers, IPMI, SNMP, and Wake on LAN. Obviously less functional. All of those can really do is control a switch, like a top-of-rack PDU. But still, it's enough to work. I can probably skip the acronym session. Does anyone here not know IPMI, SNMP, DHCP, TFTP? Okay, cool. I'll just, one thing to point out is chain loading to iPXE, way better than just using TFTP. Move all your big, even if you're not using Ironic and doing your own PXE thing, TFTP is terrible. Transfer small files over it. It's very lossy and very racy. And generally the first thing to suffer on your network if your network is congested. So what we do by default now is transfer the smallest file possible to flip into iPXE and move all of the kernel RAM disk, which are 50 megs to a few hundred megs depending on your hardware and settings, and then move the whole user image, which could be gigabytes, over HTTPS. Also, IPMI really hasn't changed in 10 years. That's a long time for software. Like, everything else in tech has changed massively in 10 years. IPMI hasn't at all. All of the new functionality in hardware is coming through additional vendor protocols. DMTF just published a thing called Redfish. They're hoping to supersede IPMI with this RESTful interface to BMCs. We'll see how far it gets. It looks interesting, but it's not either widely supported. There's not many client tools for it yet. If you want to help me, I'm kind of hacking on one in my spare time, but yeah. But really, vendor value, and this is a thing that all the hardware vendors I work with are learning this. Vendor value is derived from the hardware they're selling, the services, the support, the integration they have with it. Their value is not derived anymore from a proprietary protocol to lock you into hardware management. So they're open sourcing a lot of those tools that 10 years ago were not open source. Tools for remote firmware management, remotely flashing and updating firmware that have been proprietary for 2 decades, longer than that, are becoming open source now. And Ironic has kind of become a hub for a lot of that activity. Because there's so much hardware out there, the driver API, I've had a lot of people, after I give a talk about this, end up writing a new driver for Ironic. So I'll give a quick explanation of the internal API. The point of this API is just how simple it is. You really only have to define a power interface and a deploy interface, and that's it. And the rest is just sort of add-on optional stuff, which is why we can have an SNMP driver and it works just fine. Because it's just going to use SNMP for turning on and off the power, and then PXE, which is already written. So if you've got some crazy hardware that you'd love to have automated, it's easy to plug into this. That simplicity has given a lot of flexibility to the project to run in heterogeneous environments. So you've got, say every year you buy hardware from a different vendor, and they're all giving you different management tools. Ironic can run in that environment and control all of it, abstracted, and just knowing that here's the hardware pool of this vendor and the hardware pool of that vendor, and Ironic will cover all of that under a single abstraction layer, and still repeatably deploy the same image on all of it. The blah blah, the API, pretty simple, RESTful, blah. More detail if you want to get it. What's interesting here is this section. Can you see? No, you can't see me doing that, can you? You can see me doing, there we go. You do have to tell Ironic about the driver. So that's the part that's not abstract, right? Because every hardware is different, and every type of hardware has different required information for how to manage it. So aside from that section, the rest of the API should be entirely consistent across different hardware vendors. Yep. And it's actually been, it continues to be a bit of a challenge to make sure that stays the case. As people want to add more and more advanced features to something, it's easier, the tendency is to allow specialization to leak through. And so designing software to be a common abstraction across all kinds of hardware, from simple 1U boxes to really dense chassis, where a 4U chassis has 100 nodes in it, to supercompute things like Cray. Trying to build a single common abstraction across all of that is a challenging model to find. If that sort of problem is interesting to you, let me know. I'd love some help. Okay, operations. How am I doing on time? About halfway? Cool. Okay, so I said at the beginning of this, I used to work at HP and I'm now at IBM. I'm not actually going to talk about what either of those companies are doing with this internally. Sorry, can't. But there have been several companies that are talking publicly about it. So I'm not going to put their names up there, but Rackspace is running this in production at a pretty big scale right now. They're pretty public about that, but not saying exactly how many servers. Yahoo is doing the same thing. They're not in their public cloud. They're doing it internally as an internal management service for all their other teams. Right? So any Yahoo team that goes to deploy services in their whatever, news or mail or whatever, they're moving to their internal infrastructure management to be Ironic-based. Internap has just launched a public cloud using it. There's a couple other people that are doing the same thing. But the scale right now, most people are using it as part of Openstack. Is anyone in the room not intimately familiar with Openstack? Cool. Okay, so this is sort of the oldest picture I could find of the goal of Openstack is just being a simple abstraction of compute networking and storage. And I really want that abstraction to stay that way with bare metal and containers and VMs all under a compute bucket. I think that's a powerful thing because under the hood, it looks a little bit more like that. And if I actually put up the picture of all of the services inside each of these components, your eyes would pop out of your head. There's way too many. It's a really complex software to run, but it does seem to work. A lot of people are running it. Essentially, Ironic, I don't have a pointer would be great. Ironic integrates with the other services in OpenStack to provide those functions. The operator would actually talk to Ironic to tell Ironic, here's a pool of hardware to manage, and here's the parameters to do so. But then to the end user, you just talk to Nova or Glance or Neutron or whatever. The end user doesn't talk to Ironic to get a machine. In terms of scalability, folks are getting to thousands of servers per region managed by Ironic. And that's about the point at which scalability issues are creeping in, whether it's that parallel deploys, like if you're trying to deploy 100 nodes or 200 nodes at once, they're all going to download, let's say, the same image from your network at the same time. And if that image is 2 gigs, that's suddenly a lot of machines copying 2 gig files across the same network. So if that was your goal, so you're doing HPC workloads or genomics or something, and your job queue says, start 1,000 instances to run this thing in parallel, run it for 1 hour and tear it down. Well, it takes about, I don't know, 2 or 3 minutes to post a machine, maybe 5, depending on the hardware. Ironic will do 2 post cycles, there's 10 minutes. And then whatever the network time to copy that image is, if your network is not overloaded, maybe it's a few seconds. If it is, maybe it's 10 minutes, 20 minutes. That's not great. So you can scale that. You can do things to cache the images more locally, or have just a differently structured network that can move the data faster, or stagger the deploys. Inside of Ironic, there's a periodic health check that's monitoring all the hardware that it controls that will tell you, oh, this one's failed, take it out of the pool, it's no longer available, because I can't manage its BMC. If some BMCs are being flaky, but not bad, like they're just slow to respond, that health check cycle can get delayed. Also not great, we're working on that. If you're running this inside of OpenStack, well, the Nova scheduler isn't really great at handling hundreds of concurrent requests for thousands of resources, and this is one of the big scheduling bottlenecks, why folks are stopping at about a few thousand machines per region in Ironic right now, is the rest of the cloud doesn't quite scale in this model yet. So we're working on that. And Yahoo actually did a talk about 2 weeks ago. They've had to make a bunch of changes for Neutron and how DHCP is working in this environment. Ironic uses Neutron to dynamically change DHCP boot options for all the machines it's controlling. Turns out trying to do a whole lot of those at the same time kind of bogs down Neutron. So again, there are solutions to that, but not great yet. If you're thinking, oh my God, this sounds way too complicated. I kind of want to use this API, it looks really cool, but oh my God, OpenStack is too complex. Yes, you can run Ironic straight from Ansible. You don't need anything else in OpenStack. It might not be suitable for huge clusters. You're not going to get billing and all the fancy things you'd get with OpenStack, but you can abstract your hardware in the same way and just use Ansible, or there's a small web UI that just talks to Ironic directly. So this was a sort of project we started, I'd say about a year ago, and kind of needed a name for a project. And I felt like, gosh, this is so complex. Can't we have a bridge to make this easier for all the operators, like what I used to do in a previous life, to start using this sooner and better and just make their lives better? And so that's sort of why we started Bifrost, which is just a set of Ansible scripts to manage, well, the first one sets up the environment, second one installs all the software you need, which is pretty much 2 Python processes, a database, a rabbit bus, and Nginx. That's pretty much it. Okay. Actually going a little bit fast, but that's fine. So yeah, the first thing that one would do with Bifrost is just tell Ansible what your environment looks like, what network ranges, where the images are, what interfaces, things like that. Second thing is to install all those dependencies, just prepares the environment for PXE booting machines. So sets up DHCP, downloads an image, builds an image, things like that. The next step is to enroll the hardware. So this is where you would actually just tell Ironic, hey, here's a machine. It's got a password and a management IP address and all that. This is the characteristics of that machine. It's got a CPU architecture that kind of matters, how much memory it has. In a standalone mode like this, it wouldn't really matter, but it's kind of useful to know. If you're using Ironic inside of OpenStack, then that's matched against flavors. I see a hand.
Do you always need to edit that, or does it have any notion of introspecting information about machines?
That is a new feature supported for about the last 8 months. Yes, it does. The question was, can Ironic do introspection? Yes. I'm not going to demo that or talk too much about that. It's a side project called Ironic Discover, Ironic Discover D, that it runs a separate PXE server and coordinates with Ironic which one's going to answer the request from a machine. And it'll boot up a separate RAM disk that locally interrogates the hardware, finds out what it is, posts it back to Ironic, and leaves it in a state that a human should probably then come look at it and be like, yep, that's the machine I thought it was, or wait a minute, that's not right. Don't put that in the pool yet. And yeah, if you are doing introspection, then the only information you have to give Ironic is the management credentials, right? Tell it there is a BMC, here's how to talk to it. And you might have to give it a MAC address so it can validate when the DHCP responds that that's the machine it thought it was. And then that's what a deploy looks like if you're using Bifrost. It's just this Ansible script. We're going to trigger it, and then Ironic will run through things. So at this point, I could either do a demo or spend more time doing Q&A. Do you want to see me try and do a demo up here? Okay, cool. Oh, the fun will be my screens are not mirrored. Okay, hang on. Let me try mirroring the screens. Because I can't type while like looking up there and then down here. Okay, that should work. So I've got, excuse me, I've got Ironic running in a VM in my laptop, cabled just straight into a NUC. And I'm going to watch here on node list and node show. There's nothing registered in Ironic right now. I'm going to run the commands I showed a minute ago. Just creating a node and registering the MAC address of the NIC that it's cabled to. Oops. And while I'm doing this, if anyone does want to ask questions, go ahead. Ooh. I can try. About there. Is that closer to readable? I can make it bigger. Okay. Can't really see the watches now, but okay. Cool. There's no node. I deleted it. I'm going to create it again. All right, so it's really just the command that I had on screen a minute ago. In this case, I'm telling Ironic, there's a machine, use this RAM disk. So I've pre-cached a deploy RAM disk. What we do is we boot up another Python process on a temporary RAM disk that lets Ironic manage the machine locally. And it communicates back and forth between Ironic and the Python agent via a REST API. Going to tell Ironic, hey, it has a MAC address. Oop. Oh, yeah. Look at me, copy paste failing. I need to copy and paste that command. There we go. And now I'm going to tell Ironic, hey, here's the image I want you to deploy to that node. In this case, I've taken a Debian Jesse image and also cached it on my laptop, because it would be silly to try and download a Debian Jesse image over conference Wi-Fi. And we can see, yeah, you really can't see it that well on the screen here because the font's so big, but all the data is in Ironic. I can pull it back out of the API. Lastly, I will do the deploy. Really? I assure you it's installed. There we go. Okay. Awesome. Ta-da. Woo. Okay. Ansible's going to run. That'll take. Ooh. Oh, why did you fail? Hey, hooray for a demo fail.
So what is Ansible running against there when you're running it against
Yep.
the node?
In this case, Ansible is using a library called Shade that talks to clouds to talk to the Openstack Ironic service running in my laptop. All right, so I'm not running a whole cloud. I'm just running Ironic API under Nginx. It's just a REST API. What I was showing over here, right? This is the Ironic client, just again using REST calls to talk to the service. I could do a curl, but more typing. It's easier not to. Oh, I see what I did wrong. Okay. With the exiting and SSHing back in, I entered the wrong information. I'm going to just delete it from Ironic and re-enter it. Because I'm using shell variables here, I should know better. So if I was, say, doing this in production, what I'd probably have, say I already had a bunch of inventory in my data center. I probably already have an inventory list somewhere that keeps track of that. I would just import that into Ironic, and it's a really simple REST API. Shell scripting that would probably take a few minutes. This Bifrost product already has an importer in Ansible, but not really necessary. Let's switch the display, I think, because the Nook just turned on. Is there a button I push? Hey. In our testing of this, like my laptop is not all that powerful as computers go. I can deploy a bunch of these in parallel. Not hundreds, because network, but a bunch. The actual workload done on the host machine that's running Ironic is really minimal, aside from the network traffic. Most of the work is being done by an agent running over here, downloading an image, partitioning the disk, writing that image to the disk, copying over configuration data, putting it in a tiny little partition at the end of the disk, such that when the instance turns on, it finds that configuration, SSH keys, et cetera, and applies it. It's a great time for questions because this will take about 3 or 4 minutes. Yeah.
You mentioned something about a discovery image.
Yes.
And it's sitting at the pool.
Mm-hmm.
Have you done anything with discovery policies to say if it's in this category of node auto install to this image?
Have we done anything to set policies about automatically installing images? No. This is entirely designed to be driven by users, whether those users are humans or other systems. It's an API to present hardware to be consumed, not to dictate what is on the hardware. Question up here?
Yeah. Do you have any logic set Ironic to handle, say, that hard drives?
Do we have any logic in Ironic to handle failed hardware? Not exactly. I would do that in 2 ways. We sort of do. There is a maintenance state, but right now that's limited to checking the BMC. So if Ironic notices that a BMC has gone bad or can't reach it, it'll push that machine into maintenance mode and stop touching it. There's a process during the enrollment of the machine that you can do, which I didn't demonstrate here. It would take longer where you can do hardware burn-in and test and things like that as part of discovery. And we've got Debian on it. Yeah, done. Question in the back. You had your hand up a while ago.
What is the OS compatibility? Linux, Windows, OS X?
The OS compatibility should be anything in theory. It depends on how you deploy it. So we have 2 different modes for deploying. One is a partition image, in which case Ironic has to be able to write a bootloader that can deal with it. That's a little bit more limited. The other mode is a full disk image. And if you do a full disk image, then I mean it's just a full disk image. Ironic doesn't care what's in that payload.
So are the drivers compatible?
Not yet. Question over here? Yeah.
Have you done anything in a multi-tenant environment protecting other users from firmware changes from previous users?
So the question is, have we done anything in a multi-tenant environment? I guess that's probably a big section that I left out of this talk. Multi-tenancy at bare metal is challenging, both from a network isolation standpoint, right? You really need the network gear to support this, and there is not a good answer today in Openstack. We're working on it actively with the Neutron team to land that code right now to do arbitrate VLANs to separate tenants from each other. But in terms of firmware and the actual machine between tenants, we do support a cleaning phase. So after you delete an instance, it will boot up the same RAM disk and then run through whatever you've defined as cleaning. By default, that's just shred on all the disks. But you can plug in whatever else you want there. So Rackspace, for example, has open sourced their tools, some of their tools for firmware cleaning and things like that. And pretty much anyone who's going to do this multi-tenant has to do that. But there are still known exploits that can't be undone on common hardware. So, yeah. Question over there.
For the discovery, do you support anything like the HP onboard administrators? Instead of feeding them activists manually, you pull it out?
The question is, for discovery, do we support anything like, you're thinking of OneView or something like that? HP onboard, no. Any vendor-specific tools. Vendors are adding that support. We don't have it for all of them right now, but it's possible.
So that's bringing us to 12:30, so we're going to need to break for lunch now. Of course, you can come up and try and ask questions in person in a moment. But lunch is on the expo floor, according to my documentation, and we're reconvening at 2. So thank you for coming. Please thank our speaker.